Okay, of all the triangles that we've learned, isosceles is a very common and useful triangle. So we're going to learn some parts and relationships within isosceles triangles today. First of all, the different parts of the isosceles triangles. Remember, isosceles means that two of the legs or two of the sides are the same. So the ones that are marked with the congruency marks we call legs. The two congruent sides of an isosceles triangle are called legs. The one that is not congruent is called the base. Now, in this picture, the base is on the bottom, but it doesn't have to be. We could, whoops, guess I need my pen here. We could draw this sideways. And if I put congruency marks here and here, then these would be my legs. And my base would be, ugh, it doesn't look like any, there we go. This would be my base. So the orientation will determine where the base is in your picture on your plane, but look for the markings to determine which ones you would label leg and which one you would label base. Wherever the base is, the two angles that are coming off of it are called base angles. Okay? And then the third angle is called the vertex. It could be at the top, but it doesn't have to be. The vertex angle is the one that is made by the two legs. So be able to label your legs and base. Be able to label base angles and vertex angle. Okay, know those definitions and those placements. We have a theorem called the isosceles triangle theorem. It says that if two sides of a triangle are congruent, making it isosceles, then the angles that are opposite those two sides are also congruent. So here is an isosceles triangle. We know it because we have actual numbers, actual length values here instead of congruency marks, and they're both the same. So this is isosceles. These are our two legs because they are the two sides that are the same. According to this theorem, then the angles that are opposite these sides are also going to be congruent. Opposite meaning that we are going across the triangle. So these two angles must be congruent according to this theorem. So we would see them with the same value marked. Okay? Or we might see one value marked and the other one not, and we got to figure out what the other one is. Well, if we know that they're congruent to each other, that's easy. Here's another theorem. This one says just the opposite. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So again, it's just the opposite. Here we have our picture. We don't know that it's an isosceles triangle. All we know is that we have these two angles here that are congruent. And according to this rule, the sides opposite them, again, we're going across that triangle. Those sides opposite them would be congruent as well, making this an isosceles triangle. So if one side is 8, the other one has to be 8. So those two theorems are converses of each other, exact opposites. What else do we know about triangles? Okay, we have two corollaries, kind of additions to our rules that should be kind of common sense based on what we just learned. The first one is a triangle is equilateral if and only if it is equiangular. In other words, in order for all three sides to be congruent, all three angles have to be congruent also. Okay, think about that. In order for all three sides to be congruent, all three angles also have to be congruent. If we use our thinking of what we just learned, here's two congruent sides. Well, we learned that their opposite angles are congruent, so that means those two have to be congruent. here's another two congruent sides. So their angles opposite of them also have to be congruent. Therefore, all three of those angles are congruent. Okay, what is our second corollary? We already learned this. If we have an equilateral triangle, then each one of these angles has to be 60 degrees. Why is that? Well, we just learned if it's equilateral, it's also equiangular. That tells us that all three angles are equal, but it doesn't tell us what they are. Why do they have to be 60? Why couldn't they all three be 50 or 70 or 100? Because they all three have to add up to what's our magic number? 180 degrees. There's only one number we could put in all three of these positions so that they all add up to 180 degrees, and that number is 60. So that should become second nature to you by now, that if it's equilateral or equiangular, all three of these are 60 degrees. So let's do some problems using these ideas. Here is a diagram. Again, mark on your diagram all the information that is given to you. You know that DE is congruent to CD. So I'm going to mark it congruent on my picture so I can see it. BC is congruent to AC. And angle CDE, CDE is 120 degrees. What is the measure of BAC? Okay, well, how are we going to figure that out? We just have to work by one little piece at a time. Let's take the information that we're given here. We are not given any angle measures over here. So I'm probably not going to start there. I'm going to start over here where I have more information. If I know that this top angle is 120 degrees, can I figure out either one of these angles? Yes, I can. How am I going to do that? What do I know about these two angles? If these two sides are congruent, what do I know about these two angles now? We just learned a theorem that says these two angles are congruent. So if I called this one X, I would have to call this one X. How would I find those angle measures? Well, we know that, let me back that up. We know that all three angles have to add up to how much? 180 degrees. So I'm just taking what I've labeled those angles as and putting plus signs between them, and now I just do the algebra. If I subtract the 120 from both sides, divide by 2, then I know that each one of these angles is 30 degrees. Well, how is that going to help me over here? Okay, well then I have to start looking for related parts. I know that both of these angles with the vertex C are vertical angles. Therefore, they have to be what? Congruent to each other. So this one has to be 30 degrees. Okay, well, how's that going to help me find this angle BAC that I'm looking for? Ugh. Just let me color here. Oh my gosh. All right, you get the idea. BAC, my computer's not cooperating. Again, if these two sides are congruent, then that tells me that angle B and angle A are also congruent. I know my vertex angle is 30, so let's call this Y and Y. I can add all three angles up and make them equal to 180 degrees. Okay, do the math. I subtract, that's a 30. Subtract the 30 from the 180, I get 150, divide by 2. So the final answer is that the measure of angle BAC is going to equal 75 degrees. Lots of relationships there that we had to use and remember. Okay, here we go again. We're going to mark this up. AB is congruent to BC. AC is congruent to CD. And I know that ABC, this angle right here, is 80 degrees. What is the measure of ADC? So we're looking for this one right here. I'm going to use the same technique. This is my vertex angle. Because I know that these two sides are congruent, I know that this angle and this angle, which I would call my base angles, are congruent. Okay, I'll call them both X. So I'm going to add up the three angles and set them equal to 180 degrees. So 2x plus 80 equals 180. 2x equals 100. X equals 50. Okay, so this is 50 and this is 50. How is that going to help me find this angle here? Well, again, if I go back to my congruency marks, go back and figure out everything that you know, everything that you can say here. Okay, I know now that these two angles are congruent to each other because these two sides that are opposite them are congruent to each other. But I don't know my vertex angle this time, this angle ACD here. I do know that this side over here is 50. What is the relationship here? If this is 50, can I find this out? What kind of angles are these if they share a side? We call them adjacent angles. And when two adjacent angles make a straight line, we know that they add up to how many degrees? 180. So that means this missing part right here has to be 130. So if I can squeeze it in here, that vertex angle is 130. So using the same technique here, we'll call it y plus y. My two congruent angles are y plus the 130 degree vertex angle is going to equal 180 degrees. I can then subtract the 130 and get 50, divide by 2, and y equals 25. So my answer would be A, 25. Okay, here's another one. Name two congruent angles. Okay, well, we have two angles right here already marked. Angle PLM is congruent to angle PML. What's another pair? If I know that these two sides are congruent, then I know the angles opposite those two sides are congruent. So how would I name those? I can't name this angle L because there's two different angles here with the same vertex. So I have to name it with three letters. So I name it M, L, N, M, L, N. And that is congruent to, I could just say angle N if I wanted to. Because I used three letters here, I'm going to use three letters over here. So M, N, L. Okay. On to the next one. Name two congruent segments this time. Okay, well again, we have two that are already marked, so I can say ML is congruent to MN. But let's find some that aren't marked. because I know that these two angles are congruent, so are the sides opposite them, PM and PL. PM and PL. Which statement correctly names two congruent angles? So I'm just going to go through here and see if this statement is true. PJM, PJM, so this one right here, I might just kind of mark it with a dot, and PMJ. Those may look congruent, but I don't have any congruency marks or measures telling me that those two are congruent. I don't know that this side is congruent to this side, so I cannot say that. So now let's look at the other two, JMK, JMK, this whole big one here, and JKM, this whole big one here. It's important that you are able to have the perspective of seeing all the different triangles in this figure. We have a small triangle here, and it looks like one that is congruent to it on this side. We have a medium-sized triangle here, and another one that looks congruent on the right. We have what appears to be two right triangles, left and right triangles, and then we have this big triangle that encompasses all of them. If we look at that big triangle, notice that two of the sides are congruent. Therefore, the base angles opposite them are congruent as well. So this statement checks out. Yes, we can say that those two angles are congruent to each other. So again, you got to look at the whole picture as well as the little parts of the picture. And sometimes that's the tricky thing, is to get your brain to interpret all the different possibilities. Triangle EFG is equilateral. EFG. So I know that this, again, I'm going to mark it up. And this whole base side here, those all three are congruent. I know that EH is bisecting angle FEG. So that means that this side over here is congruent to this side over here. Mark up your pictures. EJ bisects AEG. So that means that this, I'm going to draw it differently here, is congruent to this side over here. Find HEJ, angle HEJ. Let's do that one first. First of all, if it's equilateral, we know that each one of these is 60 degrees. And so is the top one. If I split that in half with EH, then this is 30. And so is this one. And then I split that in half, so this is 15. And this is 15. So HEJ is 15 degrees. EJH. EJH. How are we going to find that? The measure of that angle right there. Well, if we have an angle bisector of an equilateral triangle, it's going to be perpendicular. So that's 90 degrees. And then we know we have 15 here, so we just need to add them up so that they equal 180 degrees. Plus, again, I'm just going to call it X. This is 105 plus something equals 180. If I subtract the 105, then I get 75 degrees. Okay, using lots of relationships that we've already learned. Use properties of equilateral triangles. We're going to skip that one since we don't have a picture with it. ABC is an equilateral triangle. AD bisects angle BAC. Find X. Okay, Well, if it bisects, that means it cuts in half. So that means this has to be 30 degrees. What is this angle over here if this is an equilateral triangle? I hope you said 60. And then we're finding x. Well, in order to find x, we got to find 3x. So what am I going to do to these three angles? I hope you said we're going to add them up and set them equal to how much? 180. So I get 90 plus 3x equals 180. If I subtract the 90, I get 90. And when I divide by 3, I get 30. B is my correct answer. Okay, and we'll stop there. It's a good 20-minute lesson. So again, know all these relationships, how to use them to solve these types of problems.